Hi, my name is Teja Hao, and today I'm going to present the assignments of circuit analysis. For the part A, I'm going to make the volume and current measurements. So you can see on the diagram, the circuit is listed now, connected with a 9-volt battery, and the current flow through multiples of resistors which is 330 ohm, 330 ohm, 1000 ohm, and 100 ohm connected together in a parallel circuit. The first step is to calculate the actual values of the current and volume that we want to obtain. From the following working, I have successfully obtained the value of current and voltage in the table, which is current A 14.27, current B 4.29, current C 9.98, voltage A 4.71, and voltage B 4.29. I have built a circuit in the Tinkercad to stimulate the following circuits in digital platform. So I connect with a power supply with 9 volt and then connect it with four the following resistors connected well with the circuit in parallel. Then I connect it with an ammeter in the first circuit to measure current A, which obtain the values of 14.3 milliampere. The second value, which is the current B, is measured as well when connect the ammeter and another circuit and obtain the value of 9.98 milliohm. The current C is also measured when connected with the ammeter and obtain the value of 4.29 milliamp. Moreover, I also measure the value of voltage by connecting it with the voltmeter. So I obtain the value of the voltage A as 4.71 volts. Voltage B is also being measured by the voltmeter with the data of 4.29 volt. The experimental data is compared with the calculated data listed in the table, and the percentage difference between manual and experimental result is just slightly different, with only volt current A with a 0.2% difference with other value which is very accurate. For part B, I'm going to make the resistance measurements with the method of Wilson bridge. So the theory is based on the formula of R1 times R3 equal to R2 times R4, which using the voltage balance and current balance to obtain the resistance unknown. First of all, the first step is to calculate actual value with the formula, which obtain the value of the resistance, which is 17.73 kilo ohm. Into the experiment, the second step is to obtain the minimum value of the potentiometer resistance, which is 0 ohm. Besides that, we also need to measure the maximum value of potentiometer resistance, which obtain the value of 35 kilo ohm. Into the experiment, the circuit is prepared in the digital platform of Tinkercad. So the breadboard is connected with our circuit with the supply of 9 voltage, and then the value of voltmeter is first measured when connected the circuit between R1 and R3 and R2 and R4. So the value of the voltage for the resistance of 25k ohm is negative 75.3 millivolt. Furthermore, the value of the potentiometer resistor is adjusted to be zero and we obtain the value of 8.89 voltage. The zero voltage balance has been achieved when we adjust the potentiometer into 17.5 kilo ohm. It means that the value of the potentiometer's or resistance is near to 17.5 kilo ohm. Then the experiment data when adjusting the potentiometer from 0 kilo ohm to 25 kilo ohm is measured and record down all the value of its voltage and current that flow through the potentiometer. And then I obtain the experimental data and put them into the graph. It brings the result that both the voltage and current decrease continuously as the resistance grow up and drop rapidly at the first and then leveling off. The Wheatstone bridge reached its perfect balance stage at 70.5 kilo ohm, where both the measured bridge voltage and current hit exactly zero. Once the resistance past this balance point, the value cross zero and become negative, indicate that the electrical direction across the center of bridge have flipped. In conclusion of this assignment, while measuring current, the multimeter is connected in series to the circuit. While measuring voltage, the multimeter is connected in parallel of the circuit. A steel-stone bridge is an electrical circuit that measures the value of an unknown electrical resistance with the formula of R1 times R2 equal to R2 times R4.